Hello. Hi, everyone. Welcome to SUSECon 23. We are here to talk to you about how we are modernizing applications to run them on containers first and then on containers in Kubernetes. And first, I think we should introduce ourselves, right? Uh, so, Cedric, do you want to go first? Do you want to introduce yourself?
Of course. So I'm senior software engineer at SUSE, working at the SUSE Manager engineering team, and working at SUSE for a very long time.
So not like me. So now my turn. I'm Miguel Perez Colino. I joined SUSE like 7, 8 months ago, and I'm taking care of the direction of engineering and product management at SUSE for SUSE Manager and indirectly of Uyuni. But Uyuni is a community project, so it has its own pace, and of course it follows community rules. So here we are. Let's talk about Uyuni and what we're doing with Uyuni. And Uyuni first is this upstream for SUSE Manager. So just whenever we say Uyuni, SUSE Manager, they're mostly interchangeable. But just letting you know that Uyuni is the upstream project, the community project, and SUSE Manager is the product that at SUSE we prepare from Uyuni so you can use it in production environments. So today we're going to talk you about the context of what we're doing about Uyuni and the project and so on, and then the challenge that we have, and then the methodology that we have been pursuing to be able to put Uyuni in containers, and then Cedric will do a demo of it. So first things first, right? Shall I?
Sure.
Shall we get started on the context?
Yes.
So let's go for it. Let's first review Uyuni and a bit of history. Okay, Uyuni is a fork of Spacewalk. Spacewalk is an open source systems management that was started in 2008, so quite a long ago right now. And it was the upstream for two products by then. Okay, it was the upstream for Satellite 5 by Red Hat and SUSE Manager before the release 3.2. Okay, the project is nowadays shut down. It was shut down on May 2020, and but we keep working on a fork of it. Next, please. Okay, so why a fork? Why forking it? So the initial intention of the team was like, okay, look, this does a lot of things. We have something called configuration channels that only allow you to put configuration in the machines, but we want to do a more automation on all the machines. Okay. By then we thought that the best automation we could add was Salt, and especially because it was very scalable. Okay, the idea of Salt is having an agent that you run in your machine, and then you connect. The agent connects to a server, gets the configuration for this machine, and applies to it. Whatever it is, running a service, adding a user, changing a configuration file, changing a file itself. Many things that you can do. Okay, the good thing about Salt is that is quite easy to use. Is almost as easy as Ansible, but as it has an agent, it scales very well. We have a customer running right now 90,000 devices with SUSE Manager in production. Okay, so on test we have done tests with more than this. So you know that okay, this is the idea. So we thought by then, let's put them together. Let's put spacewalk and salt together, and let's make it work together because it was like fitting the purpose of the customers. And I mean, it was not accepted that proposal, so we had to fork it, and we created Uyuni. We added then our React Web UI to improve the user experience and to make it more modern. And we updated the code base to run on Python 3 and Java Development Kit version 11. So we have been improving this code base, but there are some things that are still old, and we are trying to make them newer. So this is like a very nice old house made of stones with great walls and a great foundation, and we're just renewing it and making it super cool and nice. So go.
Just just be aware that the React Web UI is not rolled out everywhere, so you
Yeah,
still
yeah, yeah.
have
We
some
we still
old
need to
paint
complete
somewhere
the renewing
in some
process.
places.
We are still scratching some paintings, and but we are in the process. We're in the process, and most of it is React, and it was very nice. So next, please. So, what does it have in common with our customers? And I'm not talking about Uyuni itself, but the process of modernizing Uyuni. Okay, so Uyuni, the core of Uyuni is a Java application. So it's Java code. So we have a Java application that is running on Tomcat. So this is very, very common. I mean, I remember a survey by Jay Rebel saying that this is the most typical combination for production applications in enterprises. You know, having Java code running on Tomcat or a similar servlet for it is very common. Now we're using a Postgres database as the backend for the data, and Python code as the glue, and especially for things related to the operating system or the infrastructure, and for the UI, JavaScript and React. You know, so this is a very, very common use case that many of our customers are right now using in their own production environments, and they are thinking, hey, how do we modernize this? So as we are doing it ourselves, we are thinking, oh, why don't we share our experience, and we listen to your tips and tricks also. So here we are. So next, please. Now the challenge. This is for you, Cedric. Now go on, explain the challenge, please.
Yeah. So first, we need to talk a bit more about Uyuni. Uyuni is the upstream of SUSE Manager, as Miguel mentioned. This is a community supported project. We have monthly meetings with we call it Uyuni community hours, the
Yeah,
last Friday of the
yeah.
month.
If you
So
have
feel free to join in.
questions, please join. We are there.
And Uyuni runs on OpenSUSE Leap, whereas SUSE Manager runs on SLES. We have monthly releases, rolling releases, and the product management, product import is slightly different because it uses a command line tool in Uyuni, where in SUSE Manager you can use a wizard with SCC credentials, which you don't are not there in Uyuni. And Uyuni also has more translations than SUSE Manager. You can find all the details for GitHub, Gitter, or Twitter to follow Uyuni or join us. Um, if you have questions or want to know more, just join in. Uh, the Uyuni features, so Miguel mentioned quite a few of them already. Uyuni is scalable. It is designed in a server client infrastructure, and there are proxies in the middle. So we already
Yeah, it
containerized the
was a good
proxy
experience,
last year.
wasn't it?
As yes, yes, it was a good experience, and we did it as a first experience as a simple thing to do, and to learn on how to containerize things. And we'll see later that there are some tips and tricks that we learned from that experience. Um, so SUSE Manager is able to, and Uyuni is able to deploy and manage workloads. Is mission critical. So for users, this is something that needs to run and run for sure, and no breaks is possible. Provides hardware and software inventories, and the biggest point here I would like to highlight is, as Miguel mentioned, Uni is a fork of Spacewalk that has been officially, well, that has its first public commit in 2008, and the code dates from even before that. So it's a large code base that has grown mature, we'll say, not old, but mature. And we need to get going with this. How is Uyuni working from a very high level, right? So it's a 10,000 feet architecture view. The core piece of Uyuni is the Tomcat with the server, the Java application running as a servlet here. This is what embeds everything. The React UI will will call it. The XML PC that are running in WSGI scripts will call it as well. Um, and this web application will also have to talk to the sort master to execute actions on the sort systems. It will also have some communicate some exchanges with cobbler to set up pixie booting setups. Obviously it stores data in the PostgreSQL, and there's also a test-o-matic, which is a small daemon that is running on the server as well. It's basically a glorified cron written in Java, and processing the task from the web application, and also storing data and reading data from the database. And all of this is also served within an Apache frontend. So there's a lot of quite a number of components, and they're pretty tightly coupled together. Some are exchanging files, some are talking using APIs, and there's a nice mix there. Why do we want to go with containerization? It's not really a goal in itself. The first bullet point I wrote here is that we want to make it easy for people who are not container ready. Because containers comes with some concepts, some designs, some ideas that are sometimes new, sometimes
So we're
disturbing. So
following
we
the
want to make
principle
these
of
easy.
least annoyance, right? So if we need to change something, let's not
That's it.
annoy the user, or at least not a lot, the minimum possible. Yeah. I mean,
Yes.
which is good. I mean, you just get in the system, you can still SSH, and everything is running from system D, right? So it's, well, no, no, not yet.
SSH, no.
No, but you can
You
SSH into a
cannot
machine
SSH
that
into
is
a
running a
container.
container, right? So
Yes. Yes, we can see
yes,
that
okay,
later in
please
the
go
demo,
ahead.
but yes. And one of the biggest goal we have is to be independent from the host operating system. For now, Uni is only running on the latest Leap for as the time of recording Leap 15.4, and one person in the community is having he's running it on CentOS 8, and this is a really a big effort he's doing. And when containerizing Uni, it will be just easy. So being independent on the host operating system for people to run it on whatever they like would be very interesting. Along the same lines, the dependency management also, we want to make it easier, because for now we have to depend on dependencies that are released in SLE and Leap, and sometimes we would like to have more recent ones and so on. So putting
Mhm.
these into containers would make things easier. We also want to go towards more modularity. Containers will not make everything modular, but at least some part of it. It's a way towards it. And we want also to move towards a more maintainable and secure code. So if you have containers, separate containers, it's easier to update just one container if really required. And of course, we want to align with the container trends and wishes that users are expressing. So how do we plan to do this? Because methodology is very important if you want to do it right. The very first part is
Yeah.
to know our weaknesses.
As the
Yes.
saying
Oh,
went
my
from
weaknesses.
Garry Kasparov, you can improve your strong points, but if you really want to improve, you have to improve your weaknesses. So yeah, it's good to know them. Yeah.
Yes. And here we really want to know what are the possible pain points that we'll encounter. Like what what code could be container unfriendly. And for this, we ran Windup, which is a tool that you can run on a Java application source code, and it will help you find out the code that is not container ready. So there are some things like hard coded URLs and files exchanges, system calls, and things like that. Of course, it does not provide an exhaustive view. It doesn't replace human thinking and knowledge of the code, but it also helps discovering a few pieces. In our case, the pain points we had were files that are shared between components, mostly between the Tomcat and Salt, but not only. And we have also a lot of calls to external tools from the Tomcat code. So at some point, we'll need to figure out whether these can stay as is, as call to external tools, or if they need to be changed into something else. Um, just like calling, triggering something in another container, or what. So this needs to be monitored. Something we didn't expect and we figured out on the go when working on the setup scripts is that we are heavily depending, our setup code is heavily depending on the host name of the server, and then the fully qualified domain name. And you cannot have you cannot have control on the host name on a Kubernetes container, because if you have just a container, it's fine because it just uses the pod name as a host name. But as long as you start using deployments and replicas, then you have a variable part in that host name, and this breaks it all. So we had to work around this and not rely on host names at all. And we still have also to work on the time zone, because time zone in the containers is important for the application. So our journey, so we came up with some simple flowchart here. So we are at the first box, create single container. The idea is to just make sure we can run everything into a container, and then slowly, piece by piece,
Which is what we did
extract
for the
components.
Uyuni
So
proxy, right? And SUSE Manager proxy. Not exactly.
no,
So
we
this is
went
a
the
lesson
reverse,
learned,
and
right?
this is another. Yes, this is a lesson learned.
So it was like, okay, we should start first with a large container and give it a go to see how it goes. Okay, good. So do you recommend that,
Yes.
right?
Yes, and I even read last week an article from Martin Fowler explicitly recommending this when wanting to write a microservice ready microservice application. He was suggesting to go with the big thing and then cut piece by piece rather than go directly towards microservices. He observed that results are
Okay,
usually
so
better
the
in this way.
procedure is getting your application, putting it in a very large container, and then start finding the components that could be taken out of this. Okay,
Yes, and we'll see later. We'll see later how we can figure out which component to extract and so on. But then the point is the end box. So you see the end box here. The the point here is to find a balance on when you want to stop extracting components, um, because it can
Yeah. So there's
continue
a balance
for
between
almost
number
forever.
of components, relationship with them, interconnections, and so on. Yeah. At some point in time, you even may degrade the performance if you extract too
Yes,
many components. More complex instead of
and make it
reducing
more
the
complex.
possibilities to innovate. You're instead of increasing them, you're reducing them. So my take here is that first you have these
Yep.
large containers. You run it with something like Podman on your operating system, right? You can create a system D file to start it on boot, and then you're good to go. And then the next, okay, good,
Yeah,
good. Okay,
and we'll
sorry,
see
sorry.
that after. So, how do we decide how to cut pieces and what pieces to cut? Um, there are multiple criteria you need to think of, and first is it easy to do? Um, do we already have some container ready for this? Which is, for instance, the case for Apache or PostgreSQL. Containers are already available out there, and there's probably just configuration to tune in them to be able to use them. But even in the other containers, we'll also need to figure out, do we need to change a lot of code to use this container? For instance, the sort master could be interesting to have it as a container, but since we're exchanging a lot of files with it, we may have to change the code writing these files and use APIs instead. So these are things to figure out. What amount of code do we need to change to use these containers? And the other question to ask is, does it bring some value? Why would I want to extract such a thing into a container? And then we can go over all the usual containerization benefits, like, can I scale it? Would it be better modularization? Would it be easier to maintain, or and so on? So with all these criteria, you can start defining a list of components that can be extracted, and also start to prioritize the extraction. Now, the runtime, as Miguel
Oh,
mentioned,
good, good.
we started with Podman, because Podman is just like just like Docker for many people. It's just a simple command that you can start with. We can even write a systemd script to run the container automatically. It's easy. At least we got the whole thing
Yeah,
running
and it
into
comes with
Podman very
OpenSUSE
fast.
Leap, it comes with OpenSUSE Tumbleweed, it comes with SUSE Linux Enterprise, all of them. So yeah, you have it like almost anywhere. And
Yes.
if not, you can install it very easily.
So
Yeah.
Podman, very easy to get started.
Mm.
But then we wanted to see if that thing runs on Kubernetes. So I basically took the same image and ran it on RK2. So why RK2 is a bigger thing? Because with the proxy, I had quite a lot of troubles with the ingress with traffic. So I started with RK2, which has Nginx ingress by default, and Nginx ingress documentation is much more readable, much easier to understand. I managed to get the thing running rather fast. There were some tiny bits to adjust here, just like we mentioned earlier. Um, but we'll see them after, the differences between Kubernetes and Podman. But with Podman, it's basically just like a VM. We run everything, and it behaves just like it used to behave before. With Kubernetes, there are some adjustments here. And once all these adjustments were made, and I had Nginx set up, I tried on Kubernetes on K3S, and finally got the solution on how to set up traffic. So now it just had the traffic part
So
to
in
to
these
be worked
cases,
on
you're
for
using an
K3S.
ingress controller to get the traffic to the application, and you're offloading the SSL encryption
Yes,
to the ingress controller. Oh, okay. So sorry, I'm
we'll
going
see
one.
that
Sorry.
after a bit. Yes, there we are. So we are running everything into a single container. Since it's Leap, we're not using the
Uh-huh.
SUSE BCI init image. BCI standing for base container image, but we're using the very same thing based on OpenSUSE Leap 15.4. So it's a container that runs systemd, basically. Then we had to figure out what volumes do we need to mount to persist everything. So with such a big thing like Uyuni, we got big part of them covered very fast. But then we had to make sure we had them all. So there is only one solution: is test, 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 and test again. Restart the container, restart the machine, and test, 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 test again. Um, for Kubernetes, we had to tune this. Well, more than for Podman, we had to tune the setup. Just as I mentioned earlier, the host name was a big problem, so we had to change the setup scripts for this first. And SSL, as Miguel mentioned, SSL is not handled in the same way in Kubernetes. I had issues with the proxy containerization to get SSL to the end of the container. So this time, I decided to go with SSL termination at the ingress level, which is what is most common practice in the Kubernetes world. And this required some changes in both the setup and the Tomcat application. For instance, the Tomcat application was the one thing that was doing the redirect from HTTP to HTTPS. So, in order to avoid endless loops, I had to change this code to disable it and move the SSL redirection at the ingress level. Um, Along the same lines, we also had SSL certificates generated inside the container on Podman and inside the host on regular cases. And now this is not on Kubernetes. This is not generated at all inside the container. It's outside, which means we can use SUSE Manager to generate certificates using self-signed certificates or Let's Encrypt or whatever else. So we can just leverage the all the this ecosystem and have certificates updated for us automatically. Once I had the container working on Kubernetes, then I started writing a first Helm chart
Nice.
to make it easier to deploy.
Um,
And then
yeah,
it's again
with
test,
with
test, test,
Helm
test,
chart,
and
I
tests.
see quite a lot of people that are going to go, "Hey, Helm chart, I want to try that." This is what I use to deploy my apps.
Yes, and we're still in the process to run all the complete CI on this and make sure it's totally green. So again, the CI needs to have some tweaks here and there because some things are not behaving exactly in the same way in the container. And
So if somebody wants to try it on their own Kubernetes, they can get that Helm chart, run it, and see if things fail, and then they can come and let us know so we can work together.
y- yes, the only thing for now is that
Okay, okay.
we
So
have not released it yet. So the plan is to get the test suite
okay,
green
so they
and
don't
then
suffer
release.
as much.
Yes.
Okay, cool.
There are a few things to think from the start when working on containerizing, because it may be too late after if we plan for that later. One of the big one is migration. So how do users migrate from a non-container setup to container setup? Will you use in-place migration on the same machine, or do you want to force the user to do to prepare another machine? In the case of Uyuni, since there are some products that are required on the server, and they will not be required anymore on the new thing, we decided to go with a complete new machine, not an in-place migration. And we'll try to move all the migration scripts as much as possible outside of the container image. But this is a design choice that could be different for every application. But in our case, since it can be a bit complex, we want to make it in one tool outside. Update also, just you need to think about updates. Uni is based on RPMs, and we will still have RPMs inside the containers in container images. And what happens when you update to a new version? So it means you need to figure out if you have RPM deployed files inside the volume mounts. If you do, then you need to deal with them during updates, because you will have already your volume populated, but it will be mounted on top of the image, and the new version will be hidden then. So you need to take care of this. And as we want to make this as easy as possible for users, we're writing new tools to make it easier to work with the container, and documentation. So this getting with documentation from the start also helps beta testers and people wanting to help, making it easier. And when writing documentation, sometimes you realize some things are not that
Yeah, I
easy or
mean, the
not
limitation of
that
not
right.
being able to SSH, or, I mean, you can, of course, do a Docker execute, Podman execute, and get in the container, but that's not the usual workflow. However, when you have a regular VM
Yes,
or a physical server, is the common ways to SSH there and do things there, right? So that changes things, and these are things that need to be
yes.
taken into account for sure. I was
So
waiting
let's
for
go
it.
for a very quick demo.
Wow.
Okay, so here's my Uyuni, and you see that
Oh, so
there's no
that's a
difference.
Uni
It's
running
just
on
a
a
regular
container
Uyuni. Oh,
in your machine.
yes.
Wow. Okay,
It's just
good.
yes. Is This is a machine from our continuous integration, um, running on Kubernetes. It just runs as normal machine. You can just try to run a salt command, for instance.
So we now have one container with everything from Ujuni in one single image. Then,
Yes. So you see
uh-huh.
that salt is working, and here I'm connected.
Hmm.
So I SSH on the server, and you will see that I
What
have
do you ha-
kubectl
what do you have
get
in there? K3S
pod.
or RKE2? Okay, K3S. So I mean, we
Yes,
have two
this is
flavors
K3S.
at SUSE for Kubernetes: the Rancher Kubernetes Engine 2 (RKE) and K3S, which is the lightweight one that we use, for example, at Edge, or in this case, right?
Yes. Yes, this one
Okay,
is for is with
so.
K3S. And here you can see I have a pod running, and the host
Mhm.
name contains a variable part, as you mentioned. And we also wrote a Uyuni CTL tool that I can run
Wow.
exectish,
Oh,
and
okay, so we
and now
cannot
I'm inside the
SSH, but
container.
we can still get in there. Look at that. So cool.
Yeah, we can. So that's about it
Okay.
for the demo. Let me use the slides. Where are there? So thank you very much for your attention, and feel free to jump in the Uyuni community hours or any other Uyuni communication channel and ask questions or
Thank you for the
get
demo,
involved.
Cedric. I'm astonished. I will have to try it myself. And thanks everybody for watching, and hope to see you in SUSECon this year, and of course the coming years. Okay. Bye.
Goodbye.